Every day, we wake up to new mind-blowing discoveries that prove how much we still don't know about this universe. And while we've always had a hunch that the Earth wasn't the only planet with water, the latest discovery on Mars still has everyone shocked. In this video, we're going to talk about all the mysterious watery reflections found on Mars. Stay tuned till the end for all of this and more. First up, something other than water could be causing reflections on Mars. Researchers have discovered a new potential explanation for a puzzling signal from Mars's south pole, and it's not helping the search for water on the red planet. In 2018, scientists discovered a radar signal that was thought to have been proof of liquid water existing on the planet. The discovery was made using data from the Mars Advanced Radar for Subsurface and Ionosphere Sounding (MARSIS) instruments on board the European Space Agency's Mars Express mission. The signal, a strange bright reflection, originated from Ultima Scopuli, an area near the Martian South Pole. Instead of the ice itself or even liquid water, the signal, according to researchers studying the reflection, came from deep geological strata made up of minerals and frozen carbon dioxide. It was found that the mysterious reflections were caused by the thickness of these layers, not by what they were made of. So, while water causes these reflections on Earth, the case wasn't the same on Mars. The reflections in question were incredibly similar to the ones created by subglacial lakes. One example can be found at Lake Vostok in America, which has been buried under over 3 kilometers of ice for millions of years now. The radar signal produced by these reflections is very similar to the one scientists have discovered coming from Mars. But just because something similar could have happened on Mars doesn't mean there's liquid water there now. Up next, the investigation that ensued. The research team looked into this mystery using computer models and radar data from MARSIS. Researchers made layers of ice and other materials like basalt rock, which formed after ancient volcanic eruptions on Mars, so they could test how these materials would react to light. Dan Lalich, the study's lead author and a planetary scientist at Cornell University, made sure to include layers of this ice in the simulations. Why? Well, since there's a tremendous amount of carbon dioxide locked in the Martian South Pole, one simulation in particular, which included a layer of carbon dioxide ice beneath the water ice, showed that the distance between layers and their thickness affected how strong a reflection was. Certain minerals could also create a similar reflection, according to earlier research Lalich worked on. He thinks it's possible even in the dust-obscured ice caps of the red planet. In either case, it's very possible for the reflection to be produced with no liquid water. The latest findings don't rule out the possibility of finding liquid water on Mars, though. None of the research they've done rules out the possibility that there is liquid water there, said Lalich. Simply put, they believe that the interference theory fits the data better. They also don't think that anything short of a drill could prove that one side of this argument is right or wrong. Water and potential evidence of life might still be hidden somewhere on Mars, whether deep beneath a glacier or on the planet's charred crimson surface. Moving on to, what is MARSIS and how it works? The Mars Express orbiter's Mars Subsurface Radar Sounder, which has a 40-meter antenna, has primarily been sent to the red planet to look for water and analyze the atmosphere. The MARSIS antenna will unfold and start its radar analysis once Mars Express arrives in orbit around Mars. The MARSIS is going to search for water from the Martian surface down to a depth of around 5 kilometers, giving researchers the chance to identify direct water sources on the red planet for the first time. It will measure the red planet's elevation, surface roughness, and radar reflectivity, as well as analyze the interaction of the atmosphere and solar wind in the ionosphere. During the mission, the equipment will be able to do research that goes deep into the ground all over the planet. Researchers have already used this radar equipment on Earth with the same deployment method. It has been used to conduct successful in-depth investigations into the Antarctic and Greenland ice sheets using low-flying planes. As far as Mars is concerned, the equipment will fly over Mars with a long antenna extended, bouncing radio signals over a chosen region before picking up and analyzing the echoes. Ice would be harder to find though, since its electrical radar signal would be like rock, whereas any near-surface liquid water should emit a high signal. The materials and surface roughness can also be determined by the echoes, so it's pretty safe to say that this is going to be a monumental step in outer space studies. Lastly, the reflections from Mars could actually be clay. Bright reflections seen near Mars's south pole provide proof of water's existence. However, sight can be deceptive. A report published on July 29th in the journal Geophysical Research Letters suggests that reflections of the south pole of the red planet may result from the presence of smectite, a type of hydrated clay that is buried about a mile below the surface. Scientists working on the project came to this conclusion after using ground-penetrating radar to measure the the electrical properties of the area. The study, which was done by Isaac B. Smith of York University in Toronto, with help from Dan Lalich, says that liquid water on Earth can only exist when there are very high levels of heat and salt. The team calculated the permittivity difference between the ice and the base of the polar cap using the reflection strength, and then they compared their estimate to SMEC-type measurements taken in a laboratory. According to Lalich, the data used to verify the clay's hydration could actually be recreated from the data collected experimentally, proving that dazzling reflections do not require liquid water to produce them. So, some pretty exciting stuff awaits us in the future. Now for some other related news. To start off, astronomers discover fireworks in space. For the first time, researchers have found barium in the upper atmospheres of 2 exoplanets using the European Southern Observatory (ESO's) Very Large Telescope in Chile. Barium is a silvery white metal that is used to create green fireworks. Outside of our solar system, the WASP-76b and WASP-121b satellites orbit different stars. Both of them are gas giant planets known as hot Jupiters, which resemble our own Saturn and Jupiter. Both planets have surface temperatures of over 1,000 degrees Celsius and orbit their stars in a few Earth days. As far as WASP-76b is concerned, the exoplanet experiences iron rain that raises its dayside temperature to over 2,400 degrees. For context, that's hot enough to vaporize metals. I believe that iron vapor moves to the cooler night side of the planet, where it condenses into iron droplets. Because barium is 2.5 times heavier than iron, the researchers weren't expecting to discover it at all, considering the fact that it's the most heavy substance ever discovered in the atmosphere of an exoplanet. For the time being, the discovery only serves to increase the mystery around hot Jupiters, but hopefully we'll have some answers very soon. Moving on, the discovery of 30,000 near-Earth asteroids. Our solar system contains 30,039 near-Earth asteroids, NEAs, most of which have been found in the past 10 years. Rocky objects known as NEAs orbit the Sun and fall within a safe distance bracket from the Earth. Of the nearly 1 million asteroids that have been found in our solar system so far, they account for around 1/3 of it. Eros, the first asteroid that came close to Earth, was discovered on August 13, 1898. The about 30-kilometer wide rocky asteroid approaches Earth at a distance of 22 million kilometers, or 57 times the Moon's distance. All the NEAs that researchers have found so far do not currently pose a threat. Research also shows that we have plenty of time to research and prepare a deflection mission for those that may have an impact in the future. The search is on for a few medium-sized asteroids. According to the organization, there are still more out there that haven't been found and are harder to locate when they're smaller. That's a lot of asteroids. Lastly, did the Martians go extinct? Recent research suggests that microbes that lived on Mars in the past may have caused climate change that made the planet's atmosphere worse and led to its extinction. Researchers developed this new theory from a climate modeling study that recreated bacteria that produced methane and consumed hydrogen when they lived on Mars some 3.7 billion years ago. Atmospheric conditions at the time were comparable to those on ancient Earth at the same time. The theory proposes that the gas compositions of the 2 planets and their relative distances from the Sun caused life to flourish on Earth while dying out on Mars. Mars was farther from our star than Earth, so it needed a stronger fog of heat-trapping greenhouse gases like carbon dioxide and hydrogen to keep temperatures high enough for life. As a result, ancient Martian bacteria gradually ate the heat-trapping blanket of Mars away as they used hydrogen and created methane, eventually making Mars too cold to sustain any life, turning it into the barren wasteland it is today. That's a wrap for this video. What are your thoughts on this discovery? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.